Welcome back, my kiddos. We are now in part 2 of our balanced and unbalanced forces. This is the second and the last portion of the video of the notes. So let's go ahead and continue. When you left off on what is a net force, and like I said before, net force is the sum. And when I say sum, I'm talking about the total, right? The total of all forces. You're going to either add or subtract the force. Now, whenever you get to a problem and it's going to ask you, is the force balanced or unbalanced? If it is equal to 0, only if it's equal to 0 will that force be balanced. Anything greater than 0 will be unbalanced. So let's go ahead and do some practice problems real quick. So number 8, how do you calculate? How do you calculate net force? How do you calculate? So we know the meaning of them. We wrote the definitions down. Let's start doing some problems. So you're either going to add or subtract, right? When do you add? If, and make sure you're writing these down, your arrows point the same, if they point the same direction, you add, and we're going to underline certain words, you add the forces and include the direction. So, if your arrows point the same direction, underline that. You add the forces and include the direction. So what do Miss Allen mean? We are going to do include the direction. Now, I'm going to show you what I mean. Give me one moment. We're going to do subtracting first. Write the meaning for subtracting. So when do you subtract? When do you subtract? If your arrows point in opposite directions, underline opposite directions, you subtract. Underline subtract. You subtract the forces. And again, include the direction the force is applying. Include the direction. Now, a little side note, little fun fact. Let's label it fun fact. So we have add, put a little bubble around that, subtract, put a little bubble around that. Fun fact. The greater force determines, so how do you know which direction the object's gonna be moving? Where are you gonna look at for the greater force? The greater force determines, trying to make sure I get all of this in the frame, determines the direction. Oopsie. Determines the direction. So now we're going to do some practice problems so you can see exactly what I mean. So let's say I have an object, right? Here's my little simple object. I have an object. And I have little Andre. I have little Andre. He is pulling to the right with a net force of 10 newtons, right? And then I also have little Joseph. He is also pushing the same object in the same direction with a net force of 10 newtons. Remember what I say, if the arrows are going the same, if the arrows are pointing the same direction, we know we're going to add. So I'm going to write that in the center. We are going to add. So 10 newtons plus 10 newtons. They're going the same direction. 10 plus 10 equals 20. So your force, this is how you answer your problem. So you write out force. The force is 20 newtons. Remember, you have to include the direction. The greater force, well, since they both going to the right, this one is easy. They're both going to the right. They're both pointing to the same direction. So that's easy. They're going to be going to the right. Now, is it balanced or unbalanced? Remember, it is only balanced if the net force is equal to 0. Our net force is equals 20. Therefore, this one is definitely unbalanced. We got another room. We got some more room to do another practice problems. So here's another one. Here's a different object. Let's say I have a force acting down on it and it's applying 12 newtons. I have the same force acting on it, pulling down from it. It's also applying 7 newtons. Now notice, what direction is the arrows going? They're both going in the same direction. They're not going opposite, so I know I am going to add. The top arrow's going down, the bottom arrow's going down. They're going the same direction. And if they're going the same direction, you know we are going to add. So I have 12 newtons plus 7 newtons. 12 plus 7 equals 19. Now, how do you break down your problem, your answer? So your force is your net force is a total of, why do I want to write 12? 19 newtons. The direction is easy. I don't have neither arrow going opposite direction, so this one's going to be easy. My direction is definitely going down. Let's see. Down. Make sure I'm getting this in the frame. And then, is it balanced or unbalanced? Like I said earlier, the only time it's going to be balanced, your net force, is when it's going to be balanced is when it's equal to 0. Our net force is equal to 19. Therefore, we are working with an unbalanced situation. Let's go ahead and put a little box around our answer. Okay. Same thing for the first example problem. Okay. So we're halfway there. Let's go flip your paper over, go to the next page in your ISN. I did the same thing. I have a ruler. I had a ruler. I just drew my template on the left-hand side, about 2 inches from the left margin. Let's do some practice problems when the arrows are going opposite direction. So we have another object. All right, I have a force pulling up on an object. It is going 63 newtons upward. And then I have a force acting down on the object, and it is applying a force of 20 newtons. I notice that my arrows are going opposite direction. I have one going up. I have one going down. So let's write that down. They're going opposite. If I look at my notes, I know that when arrows are going opposite direction, I know I am going to subtract. We only add when they're going the same. I have one going up arrow, I have one arrow going up, and I have another arrow going down. Therefore, we're going to subtract. And you always start with your greater force. So that's going to be 63 newtons minus 20 newtons. 63 minus 20 is going to be 43. Now, same thing. Let's break down our problem. My force, total of 43. I should have put net force, but that's okay. Let's keep it moving. 43 newtons, right? Now, which direction is our object moving? Like our note said, Fun fact, the greater force determines the direction. Our greater force is 63, and it is going upward, so therefore our direction is going to be upward as well. So direction is going to be up. And then overall, is it balanced or unbalanced? 43 is not equal to 0, so I know that this is going to be an unbalanced example. Okay, another example. I want to make sure we all already on the same page. So here's another example. I have another object. A net force is pulling to the right of 25 newtons. And this one's a little bit off, it's okay. And I have a net force, well, a force of 30 newtons. And that's a 30 newtons pulling to the left. Again, I see my arrows are going opposite direction. So I know I'm going to subtract. Should have made my box a little bit wider. Okay, so start with your bigger number first. So I have 30 newtons minus 25 newtons. 30 minus 25 equals 5 newtons. My force is going to be, my net force is going to be a total of 5 newtons. Direction depends on the greater number, right? The greater was 30. So therefore 30 was going to the left. Therefore our object is going to be moving to the left. Overall, do we have a balance or unbalanced? I'm going to let you answer real quick. And if you guessed, what do we have? If you guessed unbalanced, then you are correct. And I'm writing faster because I don't want this video to be too long. Let me see another example. Let me give you an example of a balanced force. Okay, so let's do an example problem of a balanced force. So I have an object that is pulling to the right for 40 newtons, right? I also have a force that is pulling to the left and I'm also applying 40 newtons. 2 arrows going opposite direction, so I know I'm going to subtract. So let's write that down. They're going opposite. I know in my head that I need to subtract. 40 newtons minus 40 newtons equals 0. 0 newtons, this problem is definitely balanced. Super easy. Whenever you have a net force of 0 newtons, it doesn't say on, this is a 0, but you know that that net force is going to be balanced. Now, you will have some problems where you have a situation where you have an object right? And this time you have forces acting on all sides of an object. What do you do? Let me give you an example. So here is an object. You have a force of 2 newtons pulling upward. You also have a force pulling downward of 2 newtons. You have a force of 4 newtons pulling to the right. And then you have a force of 2 newtons pulling to the left. So what do? You're going to break it down by, You're going to break it down by direction. So looking at my forces that's acting vertical, right? Meaning I'm looking at the ones that go up and I'm looking at the ones that go down. So how do I want to write this? I'm going to write it to the right. So I have vertical, right? So looking at vertical, I have a force that is 2 newtons and it is pulling up. They're going opposite directions. So I know I'm going to subtract. Minus 2 newtons going down. Oopsie, I'm trying to squeeze that in. So that's 2 minus 2. That is going to be 0 newtons. So that part is going to be balanced. And I'm going to do another example like this too. Now looking at my horizontal. Horizontal, same thing. You always start with your greater force first. So horizontal, 4 newtons. That is pulling to the, which direction is that? The right. They go in opposite directions, so I'm going to subtract. Minus 2 newtons, that is going to the left. 4 minus 2 equals 2 newtons. The greater direction chooses the direction. The greater direction was the right. This one was also, this one is going to be unbalanced. Unbalanced, because it's 2. So overall, and I know this is going to be a little bit tricky when you get to problems like this. We are going to practice some together. Overall, it is going to be 2 newtons to the right. Since this one was 0, we're not really going to be focused on that one. So overall, it was 2 newtons to the right. All right, one more problem where it's acting, where forces are acting on both sides. Let me see if I can make a smaller drawing. That way I won't run out of room to write. Okay, so I have a force that is pulling upward. It is applying 3 newtons. I have a force that is acting on, pulling downward, is applying 1 newton. I have a force acting to the right. That is 3 newtons. And then I have a force that's pulling to the left, and that one is 1 newton. Starting with my vertical direction. I always start with the greater force. I'm talking about my vertical, so of course I'm going to be looking at the up and down one. And I'm going to be starting with 3 since that's the greater number. 3 newtons. That one is applying up, so I'm going to write that in parentheses. Opposite directions, right? So I know I'm going to subtract. 1 newton. That's going down. 3 minus 1 equals 2. The greater direction is going to be the 3, therefore it's going to be going upwards. Look at my horizontal. So I'm going to be looking at my left and right. Start with my greater force. That's going to be 3 newtons to the right, because it's going to the right. Opposite direction, so I know I'm going to subtract again. 1 newton. This one is to the left. 3 minus 1 is also 2 newtons going, which one is our greater direction? All right, so 2 newtons to the right. And forgive me for trying to squeeze this in. Okay, to the right. Hopefully you can see that. Okay, so overall, what is our net force? 2 newtons going up, and you just write down what you have. 2 newtons going up, and 2 newtons to the right. That is your answer. Now, we are almost done. Let me summarize what we discussed during our notes. Do I have room at the bottom? I believe I do. 1, 2, 3, 4. Okay, let me see if I can squeeze this in. So number 9, balance versus unbalanced forces. Let's just summarize what we discussed. So, balanced forces. Draw me a little division line. Unbalanced forces. And use these notes, you guys. We're writing all these notes for a reason. I'm going to grade them, but I want you to make sure you're paying attention and you're writing down everything that we have discussed, that I have written down. Make sure you're applying it as well. So balanced forces. You know, balanced forces, when they're balanced, that means it's no motion, no movement, no motion. It is not moving. Also, they're constant. So maybe if it is moving, but this time it's no constant, meaning there's no greater force acting on it. So therefore it's just going at the same speed. Constant motion in same direction. And then the net force, of course, will always be 0. 0 newtons. Unbalanced forces. Change in motion and position. And if I'm changing, that means I can either start, stop, speed up, or slow down in directions, right? Or change directions. How about that? Let me squeeze that in. Change directions. And then finally, the net force. Net force is always going to be 1 Newton or greater. So anything greater than 0 means I'm going to have an unbalanced force. We are done, my kiddos. When you finish, take a picture and submit to me for a grade. I know these were tedious, but hopefully you did learn a lot. I love you guys so much. Talk to you and see you later.